Point E is the midpoint of side CD in square ABCD, and BE meets diagonal AC at F. The area of quadrilateral AFED is 45. What is the area of ABCD? So for our sake, this isn't going to be true, but just so we're going to eventually talk about percentages of this square. So I'm just going to label these as coordinates. So let's call this 0, 0, that point at D. Let's call this 0, 10. This will be 10, 10. And then this will be 10, 0 right here. So I want to find the coordinate at F. So what I'll try to do is, if I know the area of this entire square, the way I've labeled it, is going to be 10 times 10, which is 100. If I can find the area of this triangle, figure out what the ratio of that is, then that's going to help us. So if I can just find this coordinate, that'll help. So the equation for this line is going to be y equals, this is the point 5, 0. So therefore, equation of this line is going to be y equals 2x minus 10. And equation for this line is going to be y equals negative x plus 10. So to find this coordinate, set the equations equal to each other. Negative x plus 10 equal to 2x minus 10. And so here we'll get 20 is equal to 3x. So 20 over 3 is equal to x, and then plug that in. So y is equal to 2 times 20 over 3 minus 10. So y equals, and 10 is 30 over 3. So y is 10 thirds. So this point F right here, the coordinate there is going to be 20 thirds, 10 thirds. And then, so from there, then we know that the base of this triangle, if we're finding out the area of EDC, 1/2 base times height, so 1/2 times 5, and then the height is just 0 to 10 thirds, so times 10 thirds. So area here is 50 over 6, or 25 over 3. And so since the area of the square is, so the way that we've labeled it, area of ABCD is equal to 100, or the same thing as 300 over 3. So we know that EDC is 1/12 the area of the square. And it's like, this isn't actually the area of the square, but just the way we've labeled it. But it is always, this area of the triangle is always going to be 1/12 the area of the whole square. Since this diagonal divides the square in half, and this is 1/12 the area of the square, then we know that this area is 5/12 the area of the square. So therefore, it's going to be true that, put this away, so it's not actually true, but this is important, so 5/12. Therefore, it's going to be true that 5/12 times ABCD, so 5/12 times the actual area of ABCD, is equal to the area of this region, which we're told is 45. So therefore, area of ABCD is 45 times 12/5, which is 108. So the answer is choice B.